In the previous unit, we looked at how to get the curve number for the loss method for each subbasin in HMS. So if we go and look at the parameters for the loss method, we will now see that all the curve number are populated. In this unit, we are going to see how to get the lag time parameter for the transform method. So to get the lag time, what we are going to do first is we are going to see how the lag time is calculated. There is an empirical method based on curve number to get lag time. So let's go ahead and look at the equation that we have for lag time. And this is the equation for lag time. So lag is equal to 0.6 times Tc, and Tc is the time of concentration, and this is the expression for time of concentration. So to get the time of concentration, we need to know L, which is the flow length, and specifically this is the maximum flow length within a subbasin. S is the maximum potential retention used in the curve number method, and the expression for S is 1000 divided by curve number minus 10. So this S uses the curve number which we already have for each subbasin. The next variable that we have in the time of concentration expression is Y, which is the average watershed slope. So in order to calculate lag, we need to have the maximum flow length. We need to know what S is, which is based on curve number, and then we need to know what the average watershed slope is. So we have the curve number from which we can calculate S. Let's see where do we get Y, which is the average watershed slope, and L, which is the maximum flow length. To get the maximum flow length and watershed slope, we can go to parameters and look at the characteristics for subbasin. And then you will see this table, and in this table we have the longest flow path length in kilometer, the first column, and then we also have the basin slope, this column here where you see the cursor moving, and all we have to do now is we have to get these in the same Excel file or DBF file where we have the curve number, and then we can use the expression that we just saw for lag time to calculate the lag time. So this is the DBF file if you still have it open from the previous unit. If not, go ahead and open the DBF file from where we extracted the curve number. So what I'm going to do is I'm going to just delete the information that I don't want. So mean this was our curve number. Now I will get the flow length in kilometer and the slope, which is Y, from the characteristic table we just saw. So our subbasins are organized alphabetically. So let's sort our subbasins alphabetically in HMS. So I'm back in HMS now. So alphabetically, and let's copy this column. So you select the column, right click, copy. Again, you go back to Excel and paste it here. So we have our length in kilometer. Now let's get the watershed slope. So again, I will go to HMS and get the basin slope column. Make sure your subbasins are alphabetically sorted. So copy and paste. So we have the curve number. So from curve number we can calculate S. So S is 1000 divided by Cn, which is this column, minus 10. Then we have L in kilometers, so I can calculate L in feet now. So we have to multiply it by a factor, which is L times 3208.8. 84. That will give length in feet, and this is y is the slope, so we want y in percentage. So I'll multiply this by 100. And once you have that, then you can calculate the time of concentration by using this expression, and then our lag, which will be in hour, will be 0.6 times Tc that you get here. And then if you want, you can calculate the lag in minutes, because that's what HMS needs. So lag in minutes will be lag in hour times 60. So I have done these calculations, and this is how my final output looks. So this is the information that we need: lag time in minutes for each sub-basin. So all my sub-basins are alphabetically sorted. So what I'm going to do is I'm going to simply copy this and go back to my HMS, and then we will go to parameters, transform, SCS unit, hydrograph, and lag time. So this is where I'll paste my values from Excel and say apply and close. And now you will see that the lag time is assigned for the transform method for each sub-basin, and that is in minutes. And for loss, we have the curve number, and usually the initial abstraction is calculated as 0.2 times S, and we just saw how S gets calculated. When we leave initial abstraction blank for each sub-basin, the program calculates it as 0.2 times S. And sometimes what happens is, if our rainfall is not enough, we get zero runoff, and that results in no hydrograph. So in all my first iteration, I put initial abstraction equal to 0 for all sub-basin, just to make sure we get some flow, and if that flow is very high, then I leave this blank and let the program calculate initial abstraction. So this is what we will do. We will put our initial abstraction equal to 0 for all sub-basin for our first iteration. So to do that, I'll go to parameters, loss, SCS curve number, and again all elements, and let's put initial abstraction equal to 0. So 0, so let's just put 0 for all sub-basins, apply and close. So now we have parameters assigned for the loss method and transform method for all sub-basins. The next thing we are going to do is assign parameter for all our reaches. So the method that we used for routing through reach is Muskingum, and we have the loss gain method. So loss gain method is basically if the reach is gaining any water or losing any water. So in this case, we are going to say that it is sort of impervious, which means it is not gaining or losing any water. And Muskingum method, we have two parameters, which is k and x. And for our first iteration, we are going to use a Muskingum k value of 0.5 and Muskingum x as 0.25 for all reaches. So let's go ahead and also assign that manually for all the reaches. So to do that, we'll go to parameters, routing, and Muskingum, and then again all elements. So Muskingum k is 0.5, so we'll just put that manually for each reach. and for X we have 0.25. We'll just do this manually for each reach. And let's leave our number of sub reaches to be 1 and say apply and close. So we have now assigned all the parameters that we need for all the methods in subbasin and for reach, and our basin development is basically complete now for HMS. So the next step is to provide input to this HMS model, and that input will be provided by specifying a rainfall hydrograph, and we'll learn about that in the next unit. So save your project and you are done for this unit.